This video is a bit long, so it is accelerated in many operation links. Please understand.
Stay alert when the TIG welder makes holes in pipes or plates. Do you know how roof angles affect drilling holes in pipes and plates? A TIG welder uses a tungsten electrode to create a high-temperature arc that melts the metal or creates holes in the base material for efficiency. For example, when creating high-temperature holes in pipes for welding, we consider ways to reduce hole-making time to improve efficiency. Newcomers often first think to increase the TIG welding current. They often overlook the tungsten electrode angle. Which tungsten grind angle makes holes faster? What about the traditional method? In this video, we will conduct an experiment. Set the TIG welder's current to maximum. Experiment with maximum current. This is a 100A stainless steel pipe. All pipe cuts are the same length. If tungsten electrode angles differ under the same conditions, what will be the result? Perhaps a high-temperature arc will create a molten pool. As temperature and time rise, the pool expands. And the pool penetrates deeper. Eventually, the pool will breach the pipe. Because the pool is molten liquid, it falls like a drop of water. The pipe will burn a hole. We also gather interesting information during welding. This video shows this to you guys. Previous videos discussed the tungsten electrode angle, the relationship between the melt pool and penetration depth. Those who've seen the previous videos will understand better. Tungsten electrode burns a hole at a 10-degree angle. Tungsten electrode burns a hole at a 45-degree angle. Tungsten electrode burns a hole at a 90-degree angle. It might be hard to compare the differences. Measure roughly with a box ruler. Can you see if the hole sizes are similar? Why does this result happen? Let's compare the three images at the same time. The pipe is thin, so heat transfers quickly. Different tungsten electrode angles, but similar arc initiation time. If the molten pool expands or spills while feeding the pipe, the results will change. Results vary even with direct impact on the molten pool using tungsten or rods. The molten pool penetrates the pipe fastest at a 90-degree angle. Without impact, the opening speed is similar. Why did this result occur? To illustrate clearly, let's use a thicker iron plate, cut to the same size and under 10 mm thick. The rear panel test will take longer than the stainless steel pipe test, allowing longer infiltration observation. Using high current to heat the iron plate continuously. We can also observe the changes in the molten pool in more detail by first using a tungsten electrode at a 10-degree angle to burn a hole. Use a tungsten electrode at a 45-degree angle to burn a hole. Burn a hole at a 90-degree angle at the ridge. We can see that when using a thick iron plate, the size of the hole remains similar. Let's compare the three images simultaneously, and please observe the molten pool carefully. The process of penetrating molten stone and creating a hole differs slightly. The previous video discussed the link between ridge grinding angle and penetration depth, noting that a larger angle leads to deeper penetration. Why does this happen? A larger ridge grinding angle creates a smaller arc, focusing heat in a narrower area. This leads to less molten material, but the concentrated heat increases penetration speed, explaining the greater penetration depth in simultaneous welding. A smaller ridge grinding angle leads to a larger arc and a bigger molten pool. However, the heat is dispersed and not concentrated. As a result, the temperature effect decreases. The penetration speed slows down accordingly. Penetration depth is lower in simultaneous welding, but burning hole speed may vary. Let's illustrate this with a water-filled kettle. In welding, a droplet in the melt pool may not fall. It only falls when there is enough weight. The droplets in the melt pool will only drop. Even without weight, droplets can fall if impacted. This applies in welding too. At a 90-degree angle, penetration speed is fastest. The time to penetrate the steel is shortest. Due to the small melt pool, the liquid might not fall if it lacks weight. Over time, the molten pool enlarges and falls when heavy enough. A greater bevel angle increases penetration speed. However, the drilling speed is the slowest. Penetration speed is slowest at a 10-degree angle. It takes the longest for the molten pool to penetrate the iron plate. The large molten pool quickly fills the falling weight. Thus, the penetration speed is slower than at a 90-degree angle. But the drilling speed is a bit faster. This is unexpected without comparison. The tungsten electrode at a 45-degree angle drills fastest. This is not too sharp an angle. When using an argon welder to make holes, a sharp roof angle may not be fastest. A normal grinding angle might yield better hole results. As the saying goes, the method isn't always right. It is one method that can be applied here. That's it for this video. If you found the video helpful, like, follow, and save. Thank you for watching.